Hello and welcome back to Compiler Programming. I want to start slowly building up the sort of a standard library or functionality of the language, and that means that I need modules. Right now there is this one test for the modules, and there are a couple of things missing that would prevent me from really going in and starting taking advantage of this functionality. The first thing is that I want to make sure that the modules are cached between the executions or between imports. I'm not even sure exactly how I'm gonna test this because well, let's actually try to write a test for it. I'm not sure it will work, but we'll see. Should cache imports of the same module. Okay, so how this is gonna work? I guess what I would want to do is I would want to say A, and that would import a sample module. I want to say B, and I want to say well, right now I can't really compare them. So how would that look like? I guess I would need to get them out of there somehow and then deal with that. So right. Well, let's see. I would need to say A. So this will not work because I don't know how to compare arbitrary things right now, and this returns a scope, and I don't know how to compare scopes. I could try to get sort of both of them out somehow and then compare them in here. That might make it work, maybe. Although I'm still not sure that it will. Um, Actually, I can get individual things out of them, and those things um, should be identical. But if it's a number, then it will be equal anyway. That's not really a test if it is the same thing. Yeah, this is tricky to test, but would be easy to implement. So I guess I will not add a test for it for now, and I should just say this should to do somehow test that modules are only imported once. So when I get arbitrary comparison works, that would work, but I don't know. So I guess we'll have to YOLO it and just do it without a test. The first thing I would need to have is somewhere to cache this stuff, and I could either put it on a program or on compilation contexts. Both are actually defined in here. So I could put it in here or I can put it in here. And that's an interesting question because these objects we sort of copy around. We can create a new one every time we call a function or do something like that because it also contains things like builder and result, which is the state of the parsing, whether we succeeded or not. So that is quite interesting. I might want to split this into a couple of objects so I don't have to copy it every time. As for example, the import stuff will not really change from one thing to another. And it is also sort of global between compile time execution and regular execution. So, well, let's just stuff it somewhere in here. First, we need to have the hash map that would be module or imported module map, and the hash map from a string to I guess to a module star. And this is what is going to be there, and we're just gonna stuff it in here, and we say module map. Let's put it next to the module. We will need to initialize it when we create a compilation context. So compilation, yeah, this thing. Okay. And we would say that module, or how do they call it? Module map is hash map make of imported module map. And in the initializer, we of course need to get rid of it. We will say hash map destroy of context module map. Okay. That builds. Let's see if the tests still run. They do. Okay. So that's good. Now we can start to actually make use of this map. That would be inside of handle or import. Yeah, okay, so it's called mass import. And as you can see, it's a pretty straightforward function. It gets a context, it gets a path, and then it tries to import this stuff. Okay, and then means that we would need to, so the scope, okay. Here's what we will do. At the very start, we say if hash map has context module map file path, then return well, not so module star module is hash map get context module map. I can actually do it this way, I think. Module pointer, because then it allows me to avoid an extra lookup, I think. File path if module pointer, and we can actually do it the following way. So we'll create a module like this. If we got it from the hash map, then we would just use that, and otherwise, so module is star module pointer. Otherwise, we will do what we were doing before. Right, and here we would say star module scope. I assume something like that. does that build? Right. Okay, so that actually seems to work pretty okay. At least it builds. Let's see if it still works. It should, because we never actually put anything in this map yet. Now we are ready to do that. We actually, in the test, at least what I will do is I will allow should I would say that should support importing the same module multiple times. So I will not check that it's going to be cached, but I would at least check that it is allowed to do it like this. This already will be better, and this should work. Actually, this will not work, and this is another thing that I will need to fix, but I can change that. So there were some changes to how I handle literal numbers, and that's still something I'm not 100% happy with, but we'll see. I think actually I should be able to make that work, but it's not something I'm working on right now. Okay, so we have A and B. We are trying to sum them up, and I want to do the following. I want to say hash map set of context module map, file path, and module. Okay, does that still work? Let's see. Okay, everything is great. We can even at least manually verify that we are indeed exercising the new code path. So we should have a panic now. Yeah, we do. Great. So the caching seems to work as it's supposed to, and everything else also works just fine. So that's great. That is the first part. Actually, there is a bit more to it. So right now we are not normalizing the path. So I'm not sure if I want to do it right now because it's a bit fiddly to work. And also I need to normalize these slashes, or maybe I should. Honestly, maybe I should. But let's still commit this separately. Commit episode 148, and that would be cache imported modules. Okay, well, let's maybe fix first this stuff, and then, or right away, we'll see if this even works. Maybe it just works right now, but we still need to normalize this. Okay. So let's do this. Mass and normalize import path. It gets a slice. It needs to have an allocator because it will copy the path, and also it will accept the slice original path. So there are a few things that we need to do for normalization. The one is normalizing the slashes, and then another one is normalizing the sort of the dots in the path. So let's go then one by one. The first thing I will do is I will say a64 length is actually no, I don't need that. I can do like raw, so it is a nice and small variable name, and I need to create some memory. So that would be u8 star result bytes or something is allocator allocate bytes, I think, allocator, and then I would just say raw length. Then I need to copy the memory, so that would be mem copy, and then result bytes, raw bytes, raw length. So we just or no, actually I shouldn't do the copy, I should do the copy myself. So we'll say the following. Damn it. 64i is 0, I is less than result or raw length I, and now we can do switch of I case. So if we have Windows style slash, then we will turn it into a Unix style slash. So we'll just say result bytes I is this. If we have there's a question if I want to normalize like slash slash stuff or let the operating system handle that. So there is a question, right? If I have something like this, right, what does it do? And there are two options. One is it's an error, and the other option is you just collapse these and leave them as they are. I will just leave it, not do it, and then think what is the better option for this. Okay. I can also do this slightly inefficiently, but much faster, implement it much easier. So maybe that's what I should be doing. Yeah, let me actually do the simple version, and then if I want to optimize it later, I will optimize it later. And the way the simple version works is it's sort of the same thing as I was doing right now. Bytes is so first we copy while normalizing the slashes. Copy and normalize the slashes. Then I will use slice split by slice. So this is an nifty method where I can say so array slice segments is allocator. Actually, I will use default because I will just throw away this thing as soon as I'm done. Slice split by slice, either like split by length, split by callback, tier name, path name. I will actually have a normalized path. Nice, I already forgot about this. Which does the right thing, I think. Yeah, it doesn't normalize the slashes. but it does do the right thing. Okay, well, I mean, I guess I might as well just use that thing. How does it work? Right. So I need to do. It's kind of unfortunate that it returns this slice because I would like it to give me non-constant memory. Well, we'll do it slightly inefficiently. Normalized slashes is bytes, sound bytes, length is the raw length. Honestly, I can do it like this. Let's use a ternary here. So it's actually slightly easier to read. Okay. And even though it's not necessary, I like to put this in braces, again for readability reasons. So we copied the string, and now we can do return slice normalized pass of allocator and normalized slashes. Right. So I do have to do it like this. That's an alignment argument. Okay. Maybe it's nicer to do it like this. Align of U8. So it's more explicit what the argument is. Cool. So we now can do file path is normalized import of text allocator. Realistically, I'm not interested in the file path. Well, no, it's going to be used as a key here, so okay, I'll have to give it around. Text allocator file path. This is all not very nice in terms of memory, but oh well. I can survive that for now. I can put the comment here. Speed. Okay. So that should help us with let's remove these things. Actually, let's leave it like this. And it should still work if I haven't messed it up anywhere. It does, and let's verify that we are still hitting this case, that even though the paths are now have different slashes, we are. Okay, and I even want to verify that this would work. So I would say foo slash dot dot slash sample. So these are now equivalent, right? We go into a folder, we get out, and then we go into something else. Let's verify that that is also works. And it does. And it's awesome. Okay, so that takes care of the normalization. Maybe I should have an argument to normalize path that also takes care of the slashes. I don't know. We'll see. Okay, let's verify without our panic that the tests are passing and we are ready to commit this. We are. Great, episode 148, and that would be normalize import path before importing. Okay, so that is good. That should be quite robust. There is still a question of like root and stuff, but that's something else. And next thing is a bit more complicated, not in terms of implementation, but in terms of kind of syntax, more or less, and semantics of how I want this to work. And this is exports. So right now I just take in whatever is the like all the things that are defined here, they're now exported. So if I add like foo is whatever bar, right? This all will be available in the outer scope. And I'm not sure I want that. I would like that modules are closed down by default, and then you have to explicitly export stuff. So the way I for now will make that work, and the decision might change later, is I will have exports, and then we will do it like this. So I can say exports dot dot, and that would mean that I'm going to export everything. And then we will also have a separate statement that is exports something like this. This is the second option. And the third option is probably going to be like this, or actually other way around. And essentially, you in this you export everything. In this you export specific things, right? But only under specific under the same name as they are. And in this version, you export it under a new name. I think this stuff, like this part, is sort of a pattern matching thing, and I will need to generalize it to allow it in other places. For example, there is technically no reason why, like I couldn't put it on this side of the expression somehow, or in many other places, in function calls, whatever. But for now, I'm just gonna implement it for the experts, and I'm not even sure I'm gonna implement everything here, but we will start with this version, because this should not change our tests. It should just explicitly export everything. But if we do run our tests, they should fail at least, because they don't know what to do with exports. And it doesn't. I could not parse a double state. I probably should improve the messaging here, but it gives us a correct location. It says in a sample module at line 10. So starting from here, I have no idea what to do. Great. Let's fix that. And that would be in top level statement, right? And I'm just gonna add another thing where we will check for token parse exports. Right. Actually, will copy this one. Parse exports. Cool. So let's try to to make that work. Token parse experts. And we need to do this stuff, which is just some protection and pick index, right? So we are looking for experts, and we are looking for block. That should be group tag, token group tag, curly. If not blocks, go to error. So let's do good error messages right away, where we say experts keyword must be followed by curly braces. Sounds good. Error return return, what do we return? Pick index. So for now, it's true and false. Okay. Return true then. Now we have a block, and I don't need to figure out how to parse that block correctly. For now, I'll just dump the code as it comes to my mind, and if I later want to clean it up, I will do that. So the first thing is this token view children is block on blocks group children, so it is slightly convenient. And I do the following: if children length is 1 and token match let's do it in a nested way, actually, where I say const token star only child is token view gets of children 0, child, not chili. If token match, so if only child is an operator, token match only child, token pattern source do I have token match operator? No, I don't. Okay, slice literal dot. So if it is dot there, then what do I do? Well, here we need to actually decide what expert does, and I think I need to change the definition of the module. So how do I want to do this? I could just stash these mappings separately, or I could just use a new scope for that. I guess it's an interesting question. Where is the module defined again? Is it in here? Here? I guess it's defined in here. Yeah, it's defined here. So it has a scope, and then I will have to slightly change this. So it has own scope and expert scope. That will break some things, but that's fine. Block group children, okay, that's fine. you need an ampersand, and I will say context module right. This is quite interesting. So I also need to track if I already had exports statement. So another thing that I need to say here inside the module is something like bool um, has exports. Let me actually do it as a flag right away because there are probably going to be more flags on the module. So module flags, and this would be has exports, I guess. And now I can put it into here. Module flags. And I will actually have to do something else now. So I made a change where I have to make all the padding explicit in structs. So module flags padding, otherwise this will not build. This is just something to protect me from mem copy problems or mem compare. Okay, getting back to this. Now I can do this check and say if context module flags has experts. That's actually already an error because we don't want multiple expert statements. I don't want to be in a business of merging them into one or something like this. Maybe later, but for now, that's not allowed. A module cannot have multiple experts statements. I should probably to do track original experts. So maybe a flag wasn't actually a good idea here, but it's fine. Okay, so we check that we cannot have them. And the reason I needed to check that we cannot have multiple ones is because if I'm doing this kind of export, then I'm going to do a simple trick of, I will say context module on our export scope is context module on scope. And that's it. We have like scope destroy. No, I don't even have scope destroy. So link fix me remove, or I will not actually create it. Yeah, that's gonna be the strategy. Okay, let's then do this. That needs to be fixed. Fix me lookup main in exported scope. So, but I want to do it in a separate path than right now. So for now, I will do it in on scope. Okay. Well, does this? Okay, what are you doing? You're creating context. You're saying that the context scope is module on scope. Yeah, that's fine. That's correct. Context module is not a member of module. Yeah, for some reason I called it module flags, right? Yeah, that makes no sense. Right. And here is the big difference. I want to do this. Now, I need to check. So I need to say if a module expert scope, then return. I want to return an empty one. I guess I do. So scope. So then it's like this. Because now expert scope can be empty. Scope lookup force. I thought I already did it. Okay. So it's the same. Fix me. Use expert scope for this. Okay. For now though, that's gonna be on scope. Cool. So that builds. Let me get back to experts and panic. Implement partial experts. Oh, let's see if that works. And it does. So we have not hit this case. We have now experts dot here working just fine, which is great news. Let's commit that separately. And I'll say episode 148 allow a module to export all declarations, all top level declarations. Okay. I guess I will do this version as well, and I will leave this one for later, maybe, and see how that goes. So now I can cheat and look into split, something like this. Yeah, that is perfect. So if a group is not like this, okay, I do want to create an expert scope where now I need to say that context module expert scope is scope make of so we'll take the parent of the own scope, whatever that is, and that would be our expert scope. And now we have this iterator, so we will looking at the code, right? We will split on the comma, and then we will look for identifiers, and we will just say that that this identifier will map to this identifier, but it will map there as a lazy expression. So here's this is going to work. If view length is not 1, or I can actually merge this. So basically it's the same test. But the pattern here is tag. Actually, this is easier like this. Tag is not token tag ID. I think I can even nicely format that. Okay, so if it is if it's not a single identifier, then something went wrong. And I need to say to the user that, hey user, you are wrong. So experts block must contain a comma separated identifier list. Right. Okay, now we can use this view as the source range to explicitly tell people where it's wrong. Okay, I need to just use children and children. Great. And return true. Okay. Token split view, right. Item. Don't need to do that. Instead, now I know that we have const. Actually, I don't even need to do it this way. I don't need to extract a single token. What I do need to do is look at how constant definition works and do the same thing. So here I will need to define a new thing inside of an expert scope. So we are defining inside of the expert scope. I do need the name after all. Okay, that's fine. So I can say const token star name is token you get children. Actually, it's not children, it's item 0. Okay, name source. We are doing a lazy entry. Name is name. Okay, that's fine. Tokens is item, and scope is the own scope. Right. So essentially, this is exactly equivalent to this thing, with the both sides being the same thing. Only I don't have to parse it out. I implicitly define it the same way. But that is a lazy expression, and that's important because if it wouldn't be a lazy expression, then this will fail, right? Because I'm trying to export something that wasn't yet defined. But if someone tries to access this outside, what will happen is that it will look into this scope. This scope will realize it's a lazy expression, but each lazy expression has the captured scope, sort of. And then we go into the captured scope, which is going to be this outer one. It will look for this thing, and it will be happy. Right. I could also verify in like at the end of the module that I'm trying to export only the things that are available. So we can do it for that as well. Maybe we will, maybe we won't. But for now, the question is, did I implement all of this stuff correctly? Well, only one way to find out. To run the tests. Right. That's actually fine. Well, we went to the right branch. And everything works. So all this stuff seems to be working quite splendidly, which is great. Again, we can commit this part separately. Episode 148. Allow modules to specify partial exports. Okay, that seems decent. Let's actually do that thing that I mentioned about verifying that we don't export too much stuff, because a lot of these things in the language are very lazy, but I think that this statement, since we can verify it quite cheaply, it might make sense to do that. So right now, if I do this, then everything will still work perfectly fine. There will be no problem at all. Because we never actually try to look up this variable. But that's not necessarily great. So what I'm going to do is in the place where we do the parsing, which I'm not sure exactly where it is, import module. So I guess it's here that happens. Right. So we parse that and we can say like this. Can do my try parse result. Okay, and return as success, I guess. Right. And now what I can do is I can say that if module export scope. So if we have any experts whatsoever, then we need to go through them, and I can steal this loop that tells me how to go through each of the hash map. Actually, just this one. So we go through the expert scope, right? We get the entry of it, and then we verify that the own scope actually has that entry. So if not has hash map has, we check own scope, and the entry is entry name, I think it's called, or key. I think it's key. If it doesn't have that, then we would we would need to say something about that, and we will say trying to export missing declaration, and we will say the name of that declaration. Something like that. And then we can actually return context result expert scope, expert scope, expert scope. Capacity is not a member of scope. Right. That is, I need to say map here, I think. And I also need to verify that the map actually exists. So if, because there might be a scope, but scope lazily initializes the map. So I need to check that. If, and here I need to say like this. Well, actually, no. I need to check like if our expert scope has some entry, but our own scope does not even have a map, then it's still a problem. And I would say break. So now we should have an error when we try to run tests that foo is missing. Yeah, trying to export a missing declaration. I would expect to have a name here. Am I doing something wrong? I don't know. What's up with the... Right, I'm doing it actually wrong because I need to verify that entry is occupied. So where are we? Here. If not entry occupied, then continue. Because hashmap has more entries than there are things. Let's try that again. Much better. Trying to export a missing declaration foo. The source range is wrong. And right. So right now our scope entries don't have a source range, which is kind of awkward. And it's something I do need to fix. We store source range on scope entries. Okay, well, that was pretty good, I think. As I said, I will leave this one for later. I might not even implement it for now, and just leave this version as is because that one exercises more of our compiler. Let's check that the tests are running, and that would be, I guess, all for today. Let's just commit this episode 148, verify that explicit experts are actually present in the module. Cool. Well, that was quite productive, I think, and that opens up the ability for me to start actually writing some modules and making use of them, which is great. For now, that's all. Thank you very much for watching, and hopefully see you next time.